everyone. Our topic for today is about integration by trigonometric substitution. So at the end of this lesson, you should be able to evaluate integrals that involve expressions of the form a squared minus u squared, a squared plus u squared, and u squared minus a squared using trigonometric substitution. And to start, so here is the detailed step-by-step solution on how to evaluate integrals using trigonometric substitution.
Okay, so as mentioned earlier, the method of trigonometric substitution can be very effective in dealing with integrals when the integrand contain the expressions a square minus u square, a square plus u square, and u square minus a square. And the three basic substitution are the following. First, when the integrand involves a square minus u square, we will try u is equal to a sine of theta. Second, when the integrand involves a square plus u square, we will try u is equal to a tangent of theta. And when the integrand involves u square minus a square, we're going to try u is equal to a secant of theta. And we are going to illustrate trigonometric substitution by using examples that are given here in the lecture notes. But we are going to do it or to discuss the solution of the integrals in the whiteboard. I'm going to unshare now this one, and let us consider evaluating the integral of x cubed dx over the square root of 4 minus x squared. Now, you can see that the integrand involves 4 minus x squared, and this can be classified as a squared minus x squared. So that we're going to let a squared is equal to 4, and getting the square root of both sides of the equation will give us a is equal to 2. And we're going to let u squared is equal to x squared so that u is equal to x. Now, according to the specific rule, when the integrand involves a squared minus u squared, we're going to try the substitution u is equal to a sine of theta. Okay, now since u is equal to x and a is equal to 2, then we will let x is equal to 2 sine of theta. And since x is equal to 2 sine of theta, we can get the differential of both sides of the equation. Differential of x, of course, is dx. And the differential of sine of theta is cosine of theta d theta. Therefore, we will have 2 cosine of theta d theta. So we can replace the differential of x by 2 cosine of theta d theta. Now, in the integrand, now we have, of course, x squared. So we might as well get the square of both sides of the equation in x is equal to 2 sine of theta. So if x is 2 sine of theta, then getting the square of both sides of the equation will give us x squared is equal to 4 sine square of theta. Okay, so let us have now the substitution. We have square root of, okay, x cubed times the differential of x. Since x is 2 sine of x, then we will have quantity 2 sine of theta rather, okay, raised to the third power. Then we have the differential of x. The differential of x is 2 cosine of theta d theta, okay, over the denominator. And the denominator is the square root of 4 minus, okay, we had here x squared is equal to 4 sine square of theta. Therefore, we are going to replace x squared by 4 sine square of theta. Of course, we need to simplify first the resulting integrand. Now, here we have in the numerator 2 sine of theta raised to the third power is also equal to 8 sine cube of theta, right? Then we will multiply this by 2 cosine of theta d theta. And in the denominator, the radicand can be simplified by factoring out 4. 4 is a common factor. Okay, so 4, so that the other factor is 1 minus sine square of theta. Okay, now simplifying further, in the numerator, we have 8 times 2. Okay, we can write 8 times 2, which is equal to 16 before the integral sign. Okay, so 16 times the integral of sine cube of theta cosine of theta d theta over, okay, now look at the radicand. We have 4 times the quantity 1 minus sine square of theta. We have to recall that using the Pythagorean identity for sine and cosine, cosine square of theta is equal to 1 minus sine square of theta. Hence, we can replace 1 minus sine square of theta by cosine square of theta, okay, making the radicand equal to 4 cosine square of theta. Okay, simplifying further, okay, we have 16 times the integral of sine cube of theta cosine of theta d theta over, okay, now take note that the denominator can be simplified by extracting the square root of 4 cosine square of theta. The square root is 2 cosine of theta. Okay, now look at the integrand. Now, sine cube of theta cosine of theta d theta over 2 cosine of theta. Of course, we can write 1/2 before the integral sign. And please take note that we can also do cancellation. Okay, we can cancel cosine of theta in the numerator and in the denominator. Hence, the resulting integrand will be, okay, first we have 16 times 1/2, okay, integral of sine cube of theta d theta. Now, 16 times 1/2 is 8, right? Okay, now, look at the integrand, sine cube of theta d theta. Now, to evaluate this, we can do transformation. Okay, now, note that in the transformation, okay, if the integrand or if the exponent of sine is add, no, we can split off sine of the factor sine of theta, since sine of theta d theta, or negative rather, sine of theta d theta is the differential of cosine of theta. So if we will split off a sine of theta, then the integrand is written as sine square of theta times sine of theta d theta. And we can express sine square of theta in terms of cosine. Okay, now take note that sine square of theta this time is equal to 1 minus cosine square of theta. Okay, therefore, we will have 8 times the integral of quantity 1 minus cosine square of theta, okay, close quantity, times sine of theta d theta. And we can express this as sum or difference of integrals. And we need to distribute 8 also. Okay, therefore, we will have 8 times the integral of, okay, 1 times sine of theta is sine of theta, okay, times the differential of theta minus 8 times the integral of cosine square of theta times sine of theta d theta. Okay? Now, in the first integral, we can evaluate this by using the formula integral of sine of u du is equal to negative cosine of u. Okay, now take note that this is exactly in the form, okay, I mean the integrand is exactly in the form sine of u du. Therefore, the integral is equal to 8 negative cosine of u. Okay, so negative cosine of u. Okay, so negative cosine of theta. Then minus 8. Okay, take note that in the other integral, the integral of cosine square of theta times sine of theta d theta, okay, we can evaluate this by power formula. And if we will evaluate this by power formula, then we will let u is equal to cosine of theta, okay? And the differential of cosine of theta is negative sine of theta d theta. Okay, but please take note that we have sine of theta d theta in the integrand. Hence, there must be a correction factor -1, since negative differential of u is equal to sine of theta d theta. Okay, therefore, by using power formula of integration and with the correction factor, which is -1, okay, we write the correction factor -1. By power formula of integration, the integral of cosine square of theta times sine of theta d theta is cosine raised to the third of theta over 3 plus the constant of integration. Now, if we are going to simplify, then we have -8 cosine of theta minus minus is plus. So 8 times 1/3 will give us positive 8 over 3 cosine cube of theta plus the constant of integration. Okay, we're done with the integration part, but we haven't considered yet the final answer. Okay, since the variable here is theta, we need to substitute back the original variable theta. Now, please take note that we have the substitution x is equal to 2 sine of theta, and the integral here is in terms of cosine of theta. So what are we going to do here? Now, we are going to refer to a right triangle, okay? The right triangle where the acute angle is theta. Okay, wait. I will make a better right triangle. Okay, so we will let this be the acute angle theta. Okay, now we have here in the substitution, x is equal to 2 sine of theta, right? Now, if we are going to solve for sine of theta, we have to divide both sides of the equation by 2 so that sine of theta is equal to x over 2. Now, but please take note that by definition, okay, sine of theta is equal to the opposite side over the hypotenuse. So referring to the right triangle whose acute angle is theta, then the opposite side is x and the hypotenuse is 2 based on the substitution that x is equal to 2 sine of theta, or sine of theta is equal to x over 2, opposite over hypotenuse. Therefore, if we are going to find the value of the other side, the adjacent side, then the adjacent side is equal to the square root of the square of the hypotenuse, which is equal to 4, minus the square of the opposite side. Okay, therefore, the adjacent side is square root of 4 minus x squared. Now, please take note that in the integrand, we have cosine of theta. Therefore, we have to express cosine of theta in terms of the original variable x by referring to the right triangle. And cosine of theta by definition is equal to the adjacent side over the hypotenuse. Of course, the adjacent side is square root of 4 minus x squared, and the hypotenuse is equal to 2. So substituting back the original variable will give us negative 8. Now, cosine of theta is square root of 4 minus x squared. Okay, so we have to multiply this by square root of 4 minus x squared over 2. Okay, then plus 8 over 3. Okay, again, we have cosine of theta is square root of 4 minus x squared over 2. Okay, and we need to raise this to the third power plus the constant of integration. And we can still simplify this, no? Okay, now in the first term, we can do cancellation. We can cancel 2 and here. Okay, this makes, this will give us 4. Okay, so that the first term is negative 4 times the square root of 4 minus x squared. Okay, then plus 8 over 3. Okay, we get the cube of the square root of 4 minus x raised to the second power over 2, so that it will give us the square root of 4 minus x squared over 8. Now, 2 raised to the third power is 8, and the numerator is raised to the third power. Now, we can also do cancellation here. We can cancel 8 here, no, right? Okay, and we can now add the constant of integration. But we can also write this in exponential form. Now, if we want to write this in exponential form, then the integral is negative 4 times the quantity 4 minus x squared raised to 1/2. Okay, we canceled 8. Therefore, the second term is 1/3 times the quantity. Okay, if we have square root of 4 minus x squared raised to the third power, in exponential form, it gives us 4 minus x squared raised to 3 over 2 plus the constant of integration. So we were able to express the integral in terms of its original variable, the variable x. So the integral is negative 4 times the quantity 4 minus x squared raised to 1/2 plus 1/3 times the quantity 4 minus x squared raised to 3 over 2 plus the constant of integration.
So in summary, if the integrals contain expressions of the form a squared plus u squared, a squared minus u squared, or u squared minus a squared, then use the following trigonometric substitution. So for integrand with a squared plus u squared, then use the substitution u equals a tangent theta. Then if the integrand contains the expression a squared minus u squared, then use the substitution u equals a sine theta. And for u squared minus a squared, use the substitution u equals a secant theta. But make sure that before using this method, the integral should not be integrable using the simple substitution.